Alright, so today we're talking about trig function values, but in radian measure. It's going to be important that we know all of our special angles. So go ahead and fill in your ordered pairs at all those. If you think you got it, you want to come up? Alright, page 1. Yeah.
Did you show
I freaked out. Let's come on, thank you. Those are fun. I know I am. Does everybody have a calculator that wants one too? Yeah. Nice. She's got it. Perfect. Get that page here. Yay. How did you guys do with that stuff off? This one right here?
I get
0. So 0 degrees. Imagine here you are, right? Brittany, you're in the way. Sorry. Alright, so you're going over 1, but then you're not moving up or down. So that'd be like the order of pair 1, 0. Does that make sense now a little bit? Perfect. Okay. Now, we're also going to have to remember some things about our positive, negative quadrant. Alright.
students take cookies.
Okay, cookies, perfect. Good job. That's, thank you. Okay, so what we're going to work on today is you guys are going to see, we're going to find the exact value. You guys did all this stuff in degrees, but right now it looks like it's in radians. So all we're going to do is we're going to convert this from radians to degrees, and it's going to be the same thing you guys did last chapter. No different. Okay? So what we can do, okay, to do our conversion, right, we can do 2 ways. You could take your radians, and if we're going from radians into degrees, we want the pi to be in the denominator. Double D, yep. And then we can cancel out the pi. So it's really like saying 180 over 3, which is 60. Great. So what we're really going to be doing here is figuring out what's the cosine of 60. That's really what this is asking you guys for. Right? Now, have we done this? Yeah. Okay. So we're going to go to find the cosine of 60. Right? Remember, cosine is the first one, which is just 1 over 2. 1/2. Very nice. That's it. Well, where's 60 degrees? Positive. It's in the first quadrant, right? So everything's positive there. Yeah. When we have bigger ones, we got to check to see where it's small. All right. So let's try number 2. Right? Oh, sorry. Let me go back real quick. I know yesterday we talked about the other way to do a conversion is subbing in 180 for the pi. Like if you guys didn't want to actually do all this multiplying, pi is really equal to 180, right? So you can just do 180 divided by 3 and get 60. All right, so if you want to do that little shortcut, we can. So let's figure out what is, I put 180 in for my pi here. What's the angle we're talking about? All right, divided by 6, so 2 times, good. Yep, you want to convert this whole thing all at one time. So it's really like saying the sine of 210 degrees. Oh yeah, you know it, bro. Okay. Now, Paige, this is what you were talking about here?
Yeah, okay. Then you have to do it in subtract.
Yep. Same, literally the same thing we did last chapter. So we need to graph 210. Okay, here's your 180. Look to see where we're going to be positive and negative. So check out this part, because I know a lot of people always forget the negative stuff. Cam, positive or negative? Negative, because you're in the T quadrant talking about S. So we know it's going to be like the same thing as the negative sign of, well, what's our reference angle? 30. 30, great, okay. So let's think, 30 degrees. Use your ordered pair. There's the sign. Yep, negative 1/2. Perfect. Good job. Okay. Alright, why don't you guys see if you could do the next 2. Right, and I'm going to do 5 with you guys. It's a little bit, not tricky, but I just want to make sure we remember. If anybody wants to do one out there, okay. This is hard. Well, you're going to have to do the same sign and then close it out. Oh, okay.
I'm going to do this one with you.
Is it good? Yeah. That's why, like, the last chapter makes such a big deal that you guys memorizing practice. It's everything. Yeah.
I can't go like this. Yeah.
How's your ankle feeling?
Actually, I'd rather.
Really? Oh yeah, crutches. I hated them. I used crutches freshman year. First time I ever used crutches in school, and I was in Stillwater, so there were stairs, and I could never find anyone who would work the elevator when I had to use it. So I had to walk up the stairs. I was like, screw it, I'm just gonna walk on my ankle. I don't care anymore.
Alright, so C, I think we're all done with this one. Okay. You guys get tan 45, hopefully you know this one a lot. Just one, it comes up a lot. Now, if you're on number 4 and you subbed in your 180 here, this was like saying the sign of a negative 150. Good job. Alright, make sure when we have our negative degree, what way do you go? Backward.
Oh.
Yeah.
All right.
Wait, what is this? 150.
Negative 5 times 1. What is the negative?
Negative.
Yeah.
Okay, so the negative means you're going to go down. Keep in mind, like each of these is 90 degrees, so we're going down 90. We're not going to get over the 180 because we have to be less than that. So here's negative 150. Right, A, F, G, C. Is our sign going to be positive or negative here? Good, negative sign. All right, and then what's your reference? 30. Good. What's our sign at 30? 1/2. Good job. Perfect. Very nice. Not as bad as you guys thought it was going to look? Or no?
Especially missing a day.
Yeah, not as bad. All right. One thing I just want to make sure we're not forgetting about is when we have like secant, cosecant, all those reciprocal functions, we want to use what it was made up of. So we're still going to do our substitution here. Put your 180 in. Okay. So this is going to be like saying a secant of, what's 180 over 45? Good job. Okay. Now we can't go right finding the secant. What do you guys want to find first? Good. Find the cosine first. Right. Once we find the cosine to get the secant, all we have to do is flip it. Right. So cosine of 45. Radical 2 over 2. Yep. Now to get the secant, we need to flip. So 2 over 2 radical 2. Oh, you guys are great. Let's see. Oh, over what for your fin bottom? 2. Good. Okay. So now if we do our rationalizing, once we flip, okay, we got 2 radical 2 over 2. Yep. We don't want to leave it like this though. Good. Cross out the 2's. So just radical 2. Okay. It's just a lot of math. I mean, you guys all know how to rationalize. You know what just cosine 45 is. Just long. Alright, I'm going to let you guys try this next one on your own, and I want you to keep in mind that there are 2 ways to do cotan. Right? Anybody know one way? 1 over the tangent, so you guys can find the tan, and then flip. Good, or cosine over the sine, right? Do you know what the tangent is already? No, so I think this will probably be easier. Yep. Alright, so figure out what this is. 180 over 3 is going to be 60, yep. So what we want to do is figure out what's the cosine of 60 over the sine of 60. Try that one out. Yeah.
Oh, are you leaving when we go to there? Wait, which one? You're leaving it when we go to there? Are you just gonna go tomorrow or we gotta do this? Are you sure you don't need it? I like how my phone's always like this big.
Yeah, you know, I would too. Oh wait, okay, so did you find the hand and then flip that? There's two ways to do it. You found it. This is what I got. So, alright, so we did our hand, we did. What is it? I got radical three. Where did you get radical three? Wait a second.
Excuse me, if Mark Bates was in the building, would Mark in the office at this time? Mark Bates?
No, I did. Yeah, if you want to go right to cosine, you could go to cosine of 3. You can do this.
Whoopsies.
Right, which would be that's actually what you're tangent. Okay, if you want to do the tangent though, it would be the line.
So you said make sure what you're doing. Like cosine of 3 is 1
So keep going with this. So you cross those out. 1 over radical 3. Now keep going from there. Anybody get this right that wants to put it up for me?
Yeah.
Great.
Oh,
you do. That's it.
Yeah, but
Oh, what happens on the bottom when you multiply radical by itself?
yeah, I forgot to do that part. Like I thought you just times that.
Oh.
And I know you had to do that too.
Yeah, then do what you do the bottom. One half over radical 3 over 2. All right, I think hopefully you guys all got radical 3 over 3. You want through? Yeah. Okay, good. Super. All right, now we did the same thing with operations. So, you know, you guys could maybe see these being multiplied, added, subtracted, divided, right? But you're literally doing the same process. Okay? We want to figure them out individually and then multiply them together. So let's figure out what is the sine of pi over 3, what's the tangent of pi over 6. And let's figure them out by themselves, and then we'll do our multiplication. You're still going to sub in your 180. Sine at 60 should be your radical 3 over 2. Because remember your sine is second, cosine is first. Now to do your, I know, tangent is such a pain in the butt. Now tangent is the sine over the cosine, right? So 30 and 30, so these are 30 degrees. We're going to take our sine, divide it by the cosine. Got to do our copy paste flip here. Yes, it's the same thing as before. So your 2's cancel. So we get a 1 over radical 3, and we have to rationalize. So do your multiplication again. Perfect. Radical 3 over 3.
3 over 6.
Okay, so when you guys multiply, are the rules top, top, bottom, bottom?
Yeah.
Yep, okay. So when we multiply the top,
With the radical go away.
radical goes away. Yep, you're just 3.
So it's 1/2 in the end.
Good, bottom 6. Yep, which is 1/2. Maddie, what's your question? That's okay. Great. Did you get the tangent of this?
I did tan 3 over 2 divided by 1 over 2.
Okay. Oh, wait. Okay, tan. Your tan was set up wrong. You did sine over the cosine. You did cosine over sine, that's why. Maddie, what's your question there? Make sure when you guys did the tangent, sine over cosine, and it's hard to kind of keep those straight, which one goes first. I would think the T, so the S has to go on top, closer like in the alphabet. That might kind of help. Good job with that one.
Wait, what?
One, like 3 over 6. Right, why don't you guys try the next one?
I thought the answer to this one was wrong.
Okay, but you gotta actually multiply it. Oh, wait, no, it's not. This is 16. 263. Did you reorder here? You're just doing them up. What's your sign?
Hey.
There you go. Good. You want to write them off like that? Yeah, which is fine. That helps a little bit.
Yeah.
Alright, so number 8, guys. I know you guys don't usually like dealing with like the special ones, like the zeros, 180s, 270s, 360s. Right? Don't panic. Just draw out your order pair. So this is going to be, they're making for 90. Good job. Right. So I know whenever we have those, like this is 0. 0, whether it's in radians or degrees, is still just 0. Can't do anything there. So here's your 0, here's your 90. Now you guys make your ordered pair, right? This is over 1, up 0. This one's 0 over 1. Good, 0, 1, nice. Now, when we do cotan, okay, can one person tell me what is cotan made up of? You could flip tan or cosine over sine. The cotan is the cosine on top. Okay. So if we figure out, well, let's see, what is the cosine up there at the 90? 0. 0. So we have 0 over 1. What's that just going to be? 0. Okay, good. Right. Now we got to go to the 0 degree here. And flip it, you should get the same thing. Yep, you should still get a 0 on top. And 0 on top will make anything 0. 0 on the bottom is the undefined, and that's like the bad one. So now here, when you guys are looking at your secant as a 0 degree, what does secant go with? Cosine, good. So let's see, what's the cosine over here? Cosine is 1. Good. So the cosine is 1. Now if we know the cosine of 0 is 1. What can you put this over to help you? 1. Any whole number is always 1. Right. So if you flip this to get your secant, it's still going to be 1, right? If you flip it, it's still 1 over 1, which is 1. Okay. So then 0 plus 1 is just 1. I love how we see all that work just to get one. Yeah, it's great. Sometimes it happens. Guys, for time purposes, can we look at number 10? Oh, what is that? Yep, we're at that, Angie. Great. Exponent. Okay, so when you guys have an exponent, this isn't the first end, it's going to come up. It's going to come up throughout the chapter. It's just like a little bit of an introduction to you. Okay. See how this is squared? Okay. What this really means, and when we start seeing it in trig, they write it very oddly. Okay. Usually, you guys think when a whole thing is all squared, doesn't it usually look like this? Yeah. Like the whole thing squared. When we're dealing with the trig function squared, they're a pain in the butt and they put it in a weird spot. Okay. So what this means this. Okay. These mean the same thing. Okay. It's just written weird. So Angie, kind of what you just asked. If you guys have something squared, all we're going to do is figure this out first, get it as like a fraction, and then square it. Okay. Yeah, you guys are too speedy over there. Alright, well let's see. This is going to be 180. So we have the cotan of 60, yep, good. Right, let's see. Let's figure out what is the cotan of 60 going to be. Try that part out. Find cotan of 60. I would probably do cosine of 60 over the sine of 60. That's easy. I was not prepared for that one. I know, sorry. Kind of crunchy stuff. Okay, so the cosine at 60 is 1/2. Oh, no, I lied. Cosine of 60 is, no, it is 1/2. That was right, all right. Then sine of 60 is radical 3 over 2. Do a little copy change, flip. 2 should go. And I mean, I think a lot of you guys are kind of catching on what this becomes, because we've done it. Good, radical 3 over 3, you got it. Good job. Radical 3 over 3. So that's just what the cotan of 60 is. So if you want the cotan squared, all we're going to do is take your radical 3 over 3. Now we need to square that. So let's see, how do you guys square this? Yep, you get rid of the radical, and what would you do to the bottom? Square it. You're basically applying this exponent to both parts because it's just one term. Good, so this is going to be 3. What's the bottom? 9. Are you guys okay with that when we square a radical? It's just the number underneath? Okay. Yeah, nice, Chelsea. Yeah, we could definitely make that. If you guys want to make this 1/3, we can reduce it. I like it. Now the other part of this, way back up here, okay, we have the cosecant of 90. Good job. All right. Let me bring that down. Cosecant 90. All right. So I'm going to draw a little picture. What do we got? 0, 1. Okay. And you guys said, which one were you dealing with? Sine. Good. Okay. Nice. So if the sine is 1, if you flip 1 over 1, it's still 1. So is this a plus?
Yeah.
Okay, plus 1. What do you guys need here? The simple common denominator, good. 4. What do you do at the bottom? Well, 1 plus, right, 3. You give me the 4. Then you always keep the bottom the same. Now, if you guys did all this work, right, and you hate your fractions, please don't get this part wrong. Just use a calculator and do you really need to? Alright, so you could do 1/3 plus 1 and get math fraction. You would also get 4/3. Okay, which is cool. There's this app, not an app, that's the wrong word for this. You know how, like, if we were doing, like, the alpha, like, window, actually you guys have to get your, like, log thing. There's a cool little fraction thing. If you do alpha y equals on your calculator, it uses choice 1. It makes it like a fraction. So if you did, like, 1/3 plus 1, it like gives it to you already in fractions. Sweet, which is kind of cool. And alpha y equals, you just pick this choice 1, N over D. It like makes fractions up for you. Just kind of cool.
There's an app